Hello and welcome to Pragmatic VEX Volume 1. Some of the topics we will cover include point clouds, smooth point cloud filtering, camera-based occlusion, point relaxation, half edges, hash functions, k-depth neighbors, k-means clustering, quad trees, convolution kernels, shaping functions, computing the gradient of an attribute, gradient ascents, gradient descents, contour lines, flow lines on arbitrary geometry via geometric advection, caustics, adaptive subdivision, bilinear subdivision, all the way to full implementing a custom Catmull-Clark subdivision based on OpenSubdiv, where we will tap into the power of the subdivision limit surface to create isolines directly on the subdivision limit surface and sample arbitrary attributes from the subdivision limit surface, and a lot more. Dedicated chapters for aggressive performance optimizations, showing every trick in the book, including implementing a custom fuse operation using VEX, replacing many of the common subs that turn out to be bottlenecks in performance with our custom VEX-based implementations, and see how far we can push the limits of Houdini far beyond the available tools. This is a practical course rather than an academic one, and as such, every topic is demystified from its formal definitions, explained intuitively through concept drawings and demonstrated with practical examples. From beginning until the end, the entire course is filled with production-proven tips and tricks. We will also learn how to read technical papers, analyze and break down formulas, solve equations, translate and transform them in a way that is applicable to our implementation. And when there is not enough information available, we will reverse engineer the available tools in Houdini to fully match their behavior in VEX. This course is aimed to increase your technical capacity to tackle more complex production problems on your own, with complete ease and control by acquiring a deeper technical understanding of how things work in Houdini at the lowest level, with a strong applied focus on high-end feature film visual effects production. And as always, thanks for watching. So this is just basically the list of topics here I summarize in the end for like reference.
How long is the pipeline? The core phase?
Yeah, it's about like 13 hours of like a heavy, heavily edited, like, so it's not very like a free talking, but more like very much like edited content, So we can now dive into the setup. It's actually quite straightforward. First, I want to talk about the effects a bit so that we can conceptualize it. So basically, just like Fiona said, like a bit of like a peeling style effect using polygon folding methods. So it could be used for, let's say, some like modeling some kind of destruction or reconstruction. It could be done in reverse. And here I use more like hexagonal shapes to create the sense of like a cybernetic tissue. But it's up to you. Like you can use triangles or polygons, quads. All of them can be done. So here basically I use KineFX, but first I start with like a basic line to prototype the effect. So here I have like 100 points. I resample it for the curve view attribute, so to get the normalized scalar value. So I'm not actually resampling the curve. So I turn off those options. So you can use it one way like this, and you can visualize the cost attribute. And then we are doing like orient along curve to compute the up and tangent vectors. We can also visualize these. So the tangent is actually following the curve, and up vector in this case is like pointing x. So you can see here, we need these for the Rig attribute wrangle to construct its own local transform matrix, which is 4x4 matrix. So from this, you can basically see we are able to bend the curve, like without doing much work. this angle is in radians. I didn't convert it in degrees in this part, but like you can do that. And also before KineFX, if you wanted to do this, let's say in attribute triangle, you will have to accumulate all these transformations and the polygon folding yourself, so it becomes more tricky and a lot more work. This makes it much easier to prototype these kind of effects. And then here basically I have the same thing, except I'm doing the reverse of the cost, and then reversing the creation of the primitive, and then we are basically creating a circle to initialize these, to mimic like what we are doing in the cheek part of the character, and normalize n for copying the geometry. So this one is actually like the same thing. So here we are computing the normal, and we are transferring it because we need this also. In this case, you can see it's like pointing up, and then we have the same for computing the tangent. So here we are computing up vector using n and tangent, and then we are deleting the other vectors just to keep the up. So here you can see basically up is actually more like by tangent. This is where basically this is the vector we will rotate the polygons around. So this is how you can visualize it. So here, so if we do the same thing, you can see you can have this kind of effects modeled inwards or outwards, like maybe you are doing some kind of like implosion effect, or it could be the other way around, peeling. So this, because now this is working, it is easier to apply to the actual character, but we just have to prepare the geometry and the right attributes. So here basically I bring the character head, so this one, and then so I just subdivide it for more detail, and I create attribute for some noise. So you can see here just some noise for the to save as a scalar attribute. And now I use a custom node here to basically carve out this piece of the sections of the geometry using a scalar attribute. So basically what this does is like to create exact, precise cuts based on the value of this attribute. But here basically what we are doing is like anything that is equal or greater than this value is going to be carved out. So it could be inside that range or outside that range. And so if you see like outside that range basically is less than this value. So you can see these are the darker areas. So it is doing that. Or you can keep both, which in this case what we want. Or you can split the geometry. And the leading edges also, you can create them, but like this, regardless of whether the geometry is split or not. This is just for connectivity in our case. And then also there's a way to mark the new primitives, which is also very useful for adaptive workflows. In this case, there is a mode for just marking the primitives without changing the topology, so that you can add additional detail around those areas, so that when you actually perform the operation, it will be very highly detailed. Let's say there might be some kind of noise there, without like subdividing all of the geometry. So this is another thing basically. And another thing is like it also supports a few other operations like slicing and clipping, which is basically like replace clip, and slice is basically using another geometry as a second input to use their points with a custom normal, or it can compute the normal using the tangent automatically. So that way, let's say if you provide a line along the character, for example, it can split it the way you expect. But in the case of, let's say you model some character like a snake, and then you have this backbone curve, you can use the exact same curve as is, or you can like change the point count, let's say using resample to have uniform or curve-based resampling, and then feed that into this operator to basically slice it up for your own, like basically maybe you want to do some kind of like sectioning of the geometry. So this is also very useful. So also like just to show you another use case of this, let's say we have the same head. I just create a sphere and a noise and turn this into an SDF, and I save the sign distance in an attribute, so we can visualize it. So inside is negative and outside is positive. So here we can just use the same for basically carving out that section. Here I'm using 0 basically to carve out the exact SDF boundary, but you can of course change it. You can have a range, let's say like this, because the values are very small here. And then again, it's up to you, can control this, but the adaptive workflow here is actually like more interesting. And it can also open your eyes for default Houdini tools where you can basically do the same thing. So here we are just basically grouping this time, not changing the topology, and feeding that into the subdivide sub. This is also custom node, but after this you repeat it a number of times, in this case 6 levels, and as you can see, like all the detail is added around the edges, and we still don't have any borders except the original neck area. And this is the one we can basically use to carve out. And as you see, like now we have this super high detail, but without blowing out the budget. So you can see like it's 6K polygons versus 40K, which is like very negligible for this kind of detail for like level 6 subdivision. This is also something I did for the X-Men Dark Phoenix setup for face cracks. So basically, to be able to add local detail is very useful, but one catch is, and the point of this operator was that the default subdivide also like breaks out the geometry, introduces open edges. If you are using open subdiv, the default Houdini Catmull-Clark preserves the geometry, so it keeps the topology intact in regards for open edges. So that is better, but then the algorithm itself doesn't scale as fast as open subdiv. So this is a modified version that basically doesn't create holes. So it handles the adjacent primitives to basically stitch correctly. And also there is like a improved version that are inside. That is basically a brand new implementation, completely using Vex. So if you dive inside also as a quick peek, so you can see, let's say here, it's basically implementing the entire Catmull-Clark in using a number of wrangles and low-level nodes like attribute wrangles and attribute interpolate nodes, so that this is like a completely different implementation, even fixes some of the issues that are present in the open subdiv implementation. So you have like smoother result. It handles like mixed geometry where you have like closed polygons and open polygons mixed together, like fused together. So all that stuff, like you can basically see how the weights are computed. So all these things, like you can see the formulas, and actually like this is the one of the major topics in the Pragmatic Vex Volume 1. And this other tool that I just showed you, the polycarve, is actually even more comprehensive, and that is basically the part of one of the chapters out of many in the second volume of the same course. So if you look here, you can see there's a lot of functions for basically doing all this operation. And what is also interesting is like it also demonstrates the more advanced powerful workflows in Houdini, such as invoking an entire network for another place inside another network. So in this case, like everything is actually originally created as a carve operation. Any other operation is actually a derivative of that operation, meaning those operations actually invoke the carve network using different parameters, so to get different results. So in this case, you know, either feeding a point cloud to do the slicing and doing the preparation of the geometry. You can see here, like creating like a point plane projection and all this stuff for feeding into the carve network, which does the actual work, because all of them are actually the same thing. The carve itself is actually much more complex than doing a planar cut. So that is also like something, if you're interested, you can see this workflow and like how to create this basically from scratch, which is quite a lot of work. I would say more like it's still not finished, but let's say at least 5 or 6 hours of edited video just for this. And from this, if we move on, here basically what I do is I'm just selecting here by hand, but you can also use it like if you want, let's say by area to isolate smaller sections, because this is also marking every piece using a piece ID. So you can use those, and you can also say you only want to keep, let's say, the like outside, and then you can filter them based on a certain size. Maybe you don't want them too small. maybe you don't want them too big, so you can do that. But here, just to show, basically I isolate by hand. The opposite is also here with the that section left out. So what we have to do here is so I just remesh this to get like more detail, and this is so fast, so it doesn't really need much of like adaptive stuff. Like adaptivity only works like for edge-based or distance-based workflows. Here is like everything is uniform, and we need that detail everywhere. So I'm storing the point number as an attribute, so PTID. So I will need these later. So here basically we get the border points for the entire piece. Also we need these for basically a few things. So this is also very advanced workflow actually, and very useful. So it might be useful in your own workflow also. This is using mostly standard tools. So one of them is distance along geometry. So if we visualize this, it looks like this. So basically what we are doing is like we are computing the distance using the start points, which is the borders, to everywhere else in the geometry. In this case, we are using one of the newer modes, hit geodesics. So if you go inside, actually it's one of the nodes that is actually compiled. So this one is compiled. So if you unlock this from the inside, you can see other modes are available as a VEX function, but this mode is a compiled node. I find it really useful. So you can just lock it again. So basically this workflow, I used it also in the same X-Men setup for face cracks. The idea was basically to get the distance, but that time we didn't have this node. And before this node, there was fall off, but before fall off, there was nothing. So that is the time basically I had my own node for, basically I also called it fall off. Before the side effect solutions, which basically does the same thing. The surface geodesics to get the surface-based distance rather than the Euclidean distance. So in this case, if you wanted to use something like attribute transfer or any kind of point cloud lookup, they will be more in Euclidean space. So it is not as useful for us when we need to traverse the geometry along the surface. So this node is definitely very useful. And you can also see the other ones like here, distance. So there's more than one. Side effects provided like multiple for different use cases. In my case, there was only one node, like I'm just using different options, like a more monolithic design. And then another key node here is, again, from the backbone of the same face crack setup is actually doing the computing the gradient from the distance attribute. So this is also very useful because the distance is very useful, but then we need a direction to push things around. So basically there's more than one way to do this. So one way is to do like converting this data into a volume and then computing the gradient from there and then sampling that volume using your geometry. So this is one method. But if I have something more exact like this geometry, I prefer to do it on the geometry without doing approximation. So in this case, this is the same node actually I used at the time. And in Houdini, there is another node that might be less known that can actually do that also. Polyframe, but it does require, if you go here, there's attribute gradient, but it does require a point, like vector tree attribute. It has to be a vertex attribute, so it's a bit less intuitive for me. So this is just like a point attribute, and I have different traversing options. So we get this vector basically. So if we visualize this also by looking here, so you can see the vectors are pointing basically to the center. So they are gonna move to their nearest distance. After this, basically, I create another noise attribute. I call it cost, that will be used for path generation. So you can see here we have unifying noise, that is all these noises. So I use Worley for interesting patterns, and then I add like a sparse convolution, mix them together, apply some power, and then and this is the result basically. And if we apply this to find shortest path, you can see we get this very nice graph. I will say definitely like this is one of the probably like top 40 useful nodes in terms of power, not the commonality like say switch or not. Can do so many things and quite fast. So, but if we disable this, actually wait, no, if we turn this off, you can see we get like less interesting shape. This might also be something you might want to do if this is what you are looking for. But here I want more chaos. And also, yeah, basically I'm doing like the same border points, start from there and end up everywhere else. So then this is why we are doing like not start points. This is like a common workflow. And we can visualize the cost here. So you can see the cost is getting greater towards the center as we traverse the geometry more. And then I basically copy, because this is a new geometry and it doesn't retain any attributes. So we first save the point number as PTID, and I'm using that, which is also present in the original geometry, to copy gradient and normal. And also one thing is like a lot of people will use something like attribute transfer, but this will be also approximation. But because we have one-to-one match, find shortest path basically is using the exact same points. So we can actually just do attribute copy, which is faster and more exact. And also if we visualize this, you can see these vectors a bit better if I do this, for example. So you can see, let's just turn. So this is the gradient, the same vector that we saw basically. And we have normal, but the normal we can visualize from here. Actually, oh, it's a vertex attribute. I think it doesn't show here. I have to check that, but basically if you look here, it's but yeah, so I can't see why, but either way, so we also compute the up and tangent. I think it's because there's no normal here, I think. And then so we have the up and tangent. So if we visualize this also, so let's say the tangent. So the tangent is as you expect. So they are following the curves. So if we reduce them a bit, and also we can do visualize it here. So you can see they are like following the curves. And the up vector is going to be the ones, so let's, if we look here, so these will be the one we can use as a base, but of course we will compute it also ourselves. So first we do the promote normal from vertex to point, and now you can see it. I think there is maybe some issue with the vertex attribute visualization for normal for polylines. So you can see the normal is basically surface normal. So it's nothing special, but then we fuse it also to consolidate the number of points. But then we use polypath, which needs also fuse for consolidating the number of primitives. So we have now 9,000 versus 14, and the point number is from 300,000 to 14,000. So it's a huge difference. This is like very useful node. So after this, you basically have connectivity to compute minimum and maximum cost per primitive, because we don't want a global maximum and minimum cost for the entire thing for normalization, but rather we want them to be per primitive. So we normalize it using those values, and then we can also actually, like, these are already like normalized, and you can see it. And then yeah, I wanted to show the different pieces here. So here you can see each of them are different primitives. So in this case, they are separate. So we are using them for normalization. So they will be localized. And then we compute the tangent, which is the most important part. So we are using the gradient vector that we computed and the normal, which is the surface normal. And when we get the new tangent, this will look more like this. So the way you expect, it's going to be swirly vectors, which is basically, again, the same vectors we will rotate the polygons around. So we need that. And then we can turn this off also. And then this is the spline graph, basically. So this is the one we will use in many parts of the network. So, well, we can just animate it first. So you can see here. This is using now degrees. So it's very fast and interactive, just doing, again, you can control all these based on your the values that you want to massage. But basically the idea is like I'm getting the cost, running that through a ramp. And after this, what we do is like get the angle, convert it into a radians, and then use that to multiply the cost. So that will give us the angle using the ramp and the cost attribute that we have. And after that, we introduce a random value between 0.8 and 1.2 for every point. And we will multiply the square of that with the angle for more variation. And we use the very important function to do this is the pre-rotate. So instead of rotating, we just use pre-rotate to modify local transform matrix basically around this tangent vector. So the difference is like the matrix multiplication, the order matters. So in this case, it is doing it before. So that's why the result looks like this. But if you do it after, it won't look like this. It will actually like be completely different, not as useful. So these functions that SideFX edit really help. And otherwise you have to use the your own like just based on the operators, like the multiply operator. And then we delete all these attributes. So we have only this. So this is the one we will instance the original primitives. But what we have to do is first we bring the same surface and we compute the dual. So computing dual to get these hexagon-like shapes. So this is the one I mentioned, like to have this kind of like a cybernetic tissue modeling. And then we split each of them as a separate polygon. So now everything is going to be, if you look here, for example, if we check the edges, so now they're all independent. And we have the original head geometry, and we subdivide this, and we use the normal. So to compute the normal, and then we basically ray this using the minimum distance so that we can get the UVs back. So if you look here, we have no UVs, but if you look after, we have UVs. So that is why we need to do this one. And then I bring the spline graph. In this case, there is a bit of code that I wrote basically to remove the offset from each piece. So because these are not in the like these are in an arbitrary location in the world here, but we need each piece to be free from any offset if you want them to match the exact location. So we remove all those using the primitive centers and additional offsets so that it is completely zeroed out. So this is the one we do. If we find this piece in this spline graph, but some of the pieces are actually missing, so they will be skipped, like say some point is not going to have any path. So those I will mark them as a missing primitives group, and these are the ones you see here, so that I can keep them so we don't have holes when we merge these both. So you can see here we are merging it back. But basically here, once we have the instance pieces properly initialized, you can see here, so all those in the basically world origin. So we copy this on the exact geometry, so here. But the idea is like we are using this piece attribute. So the same piece attribute is used to match and then copy each element accurately. So in this case also, one important thing is like here, PT ID was a point attribute, but here it becomes a PT a primitive attribute, because the point itself, if you look here, if you zoom like closely, you can see the point became a primitive. So that's why SideFX made it like it does this automatically for you, so you don't have to like do your own lookups. So after this, basically, once we have this and we add the missing ones, you can see now we have the geometry. So if we animate it again, you can see like against very fast, you can have this kind of like damage, or maybe like this, you know, it's up to you. And the pattern is all art directable, and you can like create lag, or you know, you can have more renderization. You can activate by distance or another effector. I mean, there's so much you can do. And then basically, normally you fuse also is a bit slow, so I don't enable it for interactive purposes. But if you look, for example, close, like it will enable this kind of stuff to blend. but for interactive purpose, I just turn it off. And then if we apply the UV, for example, you can see this is how it looks, and we can bring all the other pieces. This is the rest of the geometry. So you can see now everything looks like this. And of course, if you want a bit faster speed, I just keep the head only. So from here, you can again play and see how it looks. You can model it. And of course, if it was to be used, let's say in some kind of like feature film, you will have likely secondary simulations. It could be flip, pyro to integrate it better, even vellum simulation for like skin interactions. So let's say around the face. But you can imagine like this is already like a working base setup, and you can have like you have basically unlimited control. So this is basically like more or less like how this setup is working. So yeah, like any questions? Yeah. Thanks a lot.
Weird question. I mean, definitely if you connect this to
Hello. Yeah. I have experienced many times, sometimes you do some setup in Houdini in the center of the world, everything's kind of pretty working, but when you start to put it over a rig character, it's not working. Is there any limitation, what you demo here, that might make it more harder on a rig character?
Actually, this one doesn't matter because this geometry is actually is not in the world space. I mean, it's not in the world center. So if you look here, it's actually like off center. But yeah, if you can easily do that, yeah. Like and also like even this patch is actually like a very. If you look here, you can see it's like far. Like I mean, it's not in the world origin.
Mm-hmm.
But of course, I mean, if you move it so far that like you run into like precision issues, there will be a problem. Yeah. But beyond that, yeah, it wouldn't have any issue. Basically, like they are not using none of the nodes, or the logic is actually relying on the world space. But of course, yeah, like sometimes we get assets from the environment department, for example, or animation, where everything is like so far in space, so we have to like cancel out that and then bring it back after, because the precision issues, like it doesn't deal well. Or you might do like cast everything to 64-bit, but it becomes too much of a nightmare when you're exporting the data, So I prefer, generally like keep it in like a relatively, close to center. But this one, definitely can be anywhere arbitrarily. It doesn't rely on the position of the mesh, basically.
All right, thank you.
Thank you.
Not so much a question, but just a comment about your UI.
Yes.
Because for people who are watching this presentation later on, they're going to be wondering like, what flavor of Houdini is this? That it has a like node graph that is all circle nodes and overlaid over the 3D viewport, which is very interesting because you condense actually the working space.
Oh yeah.
Yeah.
Oh yeah, like I can give some info about that, of course. Well, with the laptop, once I switched to like a laptop workflow, it became very limiting to it's very crammed, So the top 3 parts that I have to use is like the viewport and the parameters panel and the network editor. But like I was just juggling to have like all of them visible on the screen, but it's crammed. Like I either have to like split like tree style or have like floating windows. So I realized like I wanted to do something like an overlay to maximize the workspace, basically. But yeah, I mean, this is it's nothing. So like it's not basically what I did is like using just the regular Python and Qt to enhance some of the features in Houdini. Like so I'm using the some code that I wrote to customize the UI so that like I can overlay the network editor on top of the viewport. So basically, this is Qt-based function. SideFX doesn't expose these, but like the stuff about like having custom hotkeys, for example, I'm taking advantage of the network editor API. So like if I press A, it's like add node. But if I'm in, let's say WAPs, so if I press N, I get a menu for noise, so I can press like T. So it's like a more like a dual key in this case. So you can do like this A, G. So I have like all this set up throughout like years, probably like 3 years already, you know. So like constantly refining, improving. But mostly it started out of the necessity of like the rule-based context-sensitive hotkey system, and the other one is based basically to have enough space and real estate. And also like I shuffle things around, like for me, like I put the status bar at the top. I feel like that is a more important place, so I can look at the top right, you know. So I feel like I get better stuff. And also I hide everything like the menu. Even I don't need the menu, for example, you know, I find it like when you think a bit about this, I mean, I'm not like a UX expert, but just like my own intuition, only few items in the menu bar is actually useful. Like other ones, like the preferences, I edit like hotkeys or the hotkey editor, so that like I don't need to use the I don't have to use the like menu bar. And the one that is irreplaceable is actually the recent file. So I had to create a custom one for this. It's also more user friendly, as in like for touch-based interface, because that one is like sometimes you miss the menu. So yeah, beyond that, like basically I was able to replace many parts. Same for the shelves. I never need them, you know, and if I need them, I can just use them here, because anything I invoke here will be from the shelf. So like just saving maximum space. I mean, it's not like completely perfect. Like I want to replace also the animation bar, but it's like because I want more compact. I submit like a request for that, but like because right now I know like it's already compact, but I prefer even more like slim down, like very minimal, you know, like only show basic, because I'm not like animator. So in FX we don't do much keyframe, so more like seeing the time, seeing if you have a key there, and like if you have like a cached simulation and the range. So I think it could be easily like half, but it's a lot of work also, you know, and there might be some limitations of like in the implementation. But otherwise, you could definitely implement your own and replace the entire thing because of the Houdini's Python Qt functionality. And also, like I took a screenshot also here. You can see basically this is the original video I released at the time for the first prototype of this overlay network. It's like also already 3 years old. So this is actually it's also available. Like I put it on my Gumroad if anybody wants to check it out. It's actually like completely open. It's not like encrypted, so anybody can use it. It works better in Windows and Linux. macOS sometimes have issues because this is all like a window-based compositing. So it depends on the operating system to manage it properly. Some operating systems just doesn't handle it, and Qt has also their own issues. But otherwise, yeah, like, and circle nodes also, like this is something I inspired from Nayat, you know, it's like this style. Like I like also like, I actually don't like this different shape for every node. To me, this is like
Too noisy.
yeah, it's too noisy. You know, I just want to see like the node. It doesn't give me any information. The color and the name already like does give me everything I need. So I don't need like to overload it like the shapes. I find it like it's overloading like mentally more. So it's actually much more simpler. And even like if somebody pays attention, it's not the same circle that ships with Houdini. Like if you look here, there's only like 3 flags. The one with Houdini comes with 4 flags. I had to make my own because it wasn't smooth enough. It was a bit like edgy, you know, like I think it's like maybe they wanted it to be faster. So I'm very picky, you know, like just customizing.
Needs more subdivision.
Yeah, exactly, you know. So like, but all this stuff is included. And also, yeah, I know another guy was actually like took it and he extended to be more keyboard based, like Vim style Houdini workflow. I find it also interesting. But for me, like I'm not huge like just all keyboard guy, but more like doing hotkeys like a single key, so I can use like, you know, mnemonics.
Yeah, the context sensitive menu is pretty nice.
Oh yeah, that's also yeah, like all of them actually like inside the file, you know. So like they are all controlled like using these. Oh, actually, yeah, this is on the other drive, but basically like all of them are in the controlled using these files. So like if I check here, I think it was in the Houdini. So all of them are here. So the hotkey system. So you can see the hotkeys are all here. And this is basically like all this stuff that's defining those. So if you look at like noise, you can see, so the noise that I just showed is like a menu, and it shows like, so all of them is just like, it's not hard-coded, you can customize it. And if I change something, it will automatically load it. It's like hot swappable. And also you see like it has the ability to call functions. So you can call some function for some key. And also it has other modifiers like it can take selection into account. So for example, if I do something like I want more like functionality, for example, if I press W for write, actually no, if I press W without selection, it is read. But if I have selection, you get write. So then in that case, you can also use selection to further change the behavior. So like just like mentally like using the most commonly invoked operators, like the switch or null. But then I don't want null in WAPs because then it's not the same useful in subs, So all this stuff like took a lot of time to like think and design like which hotkeys are better, all this stuff like, and also like another thing is like, for example, here I have like the custom node, but then also it has stuff like if it in a different environment, it cannot find this, it will create another version. So you have all this option to say, if you can find this node, then create the regular file cache, for example, Another thing is actually like beyond space saving. There is more actually behind the scenes. It's actually like it's like a more you work in the network editor and then you look at the same place to see the result. But when you use multi-workflow, like say multiple monitoring workflows, you actually have to like look back and forth many times, But in this case, you look at the same place for both changing the parameters and the network editor, creating new nodes and the network, and also the result. And I call it like the zero head travel, so you don't have to do anything, It could be trademark, I guess. But yeah, like I don't know if, also it's not a new thing. Like I think a few other applications, even Houdini's sister app, like Touch Designer, it has this. Yeah, it has this feature. So I actually kind of got inspired from seeing this. I thought it's useful, but I know like some developers think it's a bit like maybe too confusing. But for me, no. And also like it has like adjustable transparency. If it gets like maybe like too wireframing behind to confuse the wires, you can like change the transparency. So like live and but for me it's like very rare.
Can you change it? Can we see that?
Oh yeah, let me see. Like I think it was because I don't use it all the time. I think it was you see, now I made it like completely opaque. So this is the default, more transparent. You see, I think Control F1 is the
fancy.
So 25, 50, 75, I find perfect. Because you see, like sometimes if you have this, let's say like this. So this is a bit like sometimes you might be, but it's okay. You can just do this Control F4. Now you don't worry, And also like I have other keys like to modify the viewport directly. Like sometimes, for example, let's say I have, let's say this spaceship geometry. So I load this. You see it's somewhere in space, but I don't want to like toggle the network editor back and forth. So I just press like Shift F for directly modifying the viewport like globally, So then I can just keep working. So then I can just do this. And also I even like override the default space bar volatile key for the network editor to do like hold down the key, do something, and then bring the editor back. So it has so much functionality, and also I have other things like you see, like if you look 6, it's like another network editor you can do side by side, and everything is hotkey based. Like the details view, you have performance profiler, you have other things. I have like other code for like toggling the render view, so you can do like I want to see the render in the background. Same so when I'm changing the shaders, all that stuff I find like just like basically I can't just work regular Houdini anymore.
So you don't moan every release when the keys get remapped.
Oh, that's the thing. Yeah, in that case, yeah, for me, I just see what they change and see if there is a useful change that they make that I should be bringing. But otherwise, I just use my own. Otherwise, yeah, like because the keys change all the time. Like say there's a Y key for like cutting the wire, so I thought, okay, then I'll reserve that, for it seems okay, So, but otherwise, like I don't want like the same keys, like say. I have all these like fast functions for like instead of quick marks, I'm using like 1, 2, 3, 4 those for basically like selecting the nearest, like displaying the nearest, selecting the nearest. All this functionality is like so I can just do it like this. So if you look here, even if I'm here, you can see I don't have to like worry about flags. I'm just getting the nearest. And also like I even mapped it to my here in this case right click. So if you look here, but in this case it has to be on top of the node because otherwise we have zoom functionality. So but if I do it, let's say 2 times, it will display the result. So I can just do it like this, you see. So if I do this, this is also like using just one hand, so I don't even have to use the keyboard. But of course you might say, if I do this, then what about the right click menu for the node? So that's the thing. This is also like a case by case basis. Like in WAPs, this is useful to have the right click menu, but in subs I find it like it's also not as useful. So in this case, I don't completely disable it, but like I have to use modifier for Alt to bring it up because I don't use it a lot. But otherwise, like I find it this is much more useful for me. Like I can just use it like traverse the network, just one hand basically, and quickly like change parameters, you know. And also you can even do if you wanted, let's say go like control. I think it was Shift B. I forgot hotkey for like the you know, to make it like full. Yeah. So basically like the this one maybe so basically like you can even maximize the pane. Maybe I change it to something else, you know, but basically like you can
Control
also,
B.
yeah, because you know there's like the way to maximize the pane, you know. I thought it was like Shift B or something.
Control B.
Control B. Maybe let me check
I think
the
it's
Control B because the hotkey editor.
Is it Control B or maybe it's
You see, like sometimes the
Shift
hotkey
or
editor
Alt.
also. I have hard.
one in the corner.
You see, like here, if I press B, you see, you can see here, but like this is B. But Control B, you see, like the hotkey editor, I sometimes it doesn't recognize the thing, you know. But if you do, I think here, maybe I can do this like maximize. You see, like maximize pane. Oh, you see, it says here, but it didn't do. Oh, okay. So, okay, I think this one. So if you do this, you see, even this one is it doesn't. It's a bit like confusing, you know. But normally, like I assign, you see, like you are right. It's Control B, but it doesn't work. You see, there's some issue there. But if I do, let's say Alt P, just to see, or maybe like just like Control Shift B. Like you see, there's so many hotkeys. Like, but in Houdini, this is all Houdini hotkeys, you know. So maybe like Control Shift Y. You see, even this one exists. So you have to do like what this is. So like that's why I don't like this too much hotkeys. You see, like it doesn't do that. So there's some bug, I think. Yeah. But in that case, like I was gonna show, you can maximize the entire pane to full screen and make the parameter pane visible like this. So you can also work like that, which is also very useful. But for me, I like this style. You know, it's useful enough, and I can toggle like the grid.
Zero head travel.
This is my trademark. But if SideFX wants to implement something like that, it would be cool. I mean, I do have like a 3-year head start for all ironing out the issues. So they will have like, have to fix these also, you know, because all these workflow issues bring up different issues on their own. But I think it's a good idea to give it a try. It just has a learning curve, you know. So just like using a tablet, first time it slows you down, but after a week you start getting faster. So you have to like give it a chance to really see. But for like, and it's not even like a limited space thing, because even I actually have like a 32-inch monitor at home, but I want to use just that, not the laptop. So I'm still using this because then it's like 2 monitors. So 2 monitors better than 1. So of course I still use it like that for me. Just and even the tutorial actually I made all my course, I'm using also this workflow, because some of my colleagues before told me that it might maybe confuse some people. But actually, it was actually much more successful. People told me this presentation is like more compact, and like they thought I'm doing some editing tricks, you know. But it's actually like live, because you know, like you can see the thing. And also at the end of the day, I told them like, you know, the users don't need my you know, same desktop. You know, it's not about creating a desktop, but more like what I'm showing. You know, so it's not like they will say, oh, I don't have these nodes, or I don't have these node shapes. You know. This is not as useful. Like they don't need it for the course, But either way, so yeah, I submitted already like this 3 years ago. So if anyone wants to see this in Houdini, maybe like submit your own.
Right on the forum.
Every once in a while somebody's like, hey, how does this guy do it? Like they link my tutorial because I have like free chapters also. So then people are saying, oh yeah, this is a custom thing. But yeah, if it was default, that will be really cool. Yeah.
Any other questions, comments? All right. Thank you very much, Yunus.
Thanks so much.
Thanks.
Yeah. Then I just maybe like put my social media if anybody was interested. It's like actually this video is also like maybe crime, but basically it's just a website I just showed. These are all videos they can watch either here. These are the free chapters or SideFX website. Also, SideFX graciously put it on their Vex Learning, so they can actually see it in like the if they click SideFX Learning and Vex, this course is in the end. They mark it as like advanced, and it is like almost 2 hours of free content. So you can get a feel of if you like to watch more or or not. Yeah, and it's my social media. Feel free to add me or ask some questions. Yeah. And as always, thanks for coming. I appreciate the chance to give a talk. Thanks, SideFX. Thank you so much.